Hello, 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 hello. Thank you so much for joining us this afternoon. I know you have a choice of different talks to attend and different boot camps to train at, and so really glad that you decided to join us today here. Of course, this session is about Amazon Kinesis. In case you were waiting to hear about IoT or Elasticache, this is not the right room. Just want to make sure, right? This is a 400-level session, so we're going to move very quickly through a lot of content. So before I do that, show of hands, how many of you here use Amazon Kinesis in some way or form? That's healthy. How many of you are just now getting curious about streaming data because you've heard a lot about it on stage here and through other customers and are curious? So it's a 50-50 mix. So I'm assuming that some of you do know enough about streaming data such that because it's a 400-level session, we will make certain assumptions about how much you might already know. So I'll do my very best to give you kind of a broad overview while still going deep enough for those who've been kind of deep in the trenches on Kinesis. Hopefully that will be a happy medium, although it's never been known to work. We'll try that out. But really, what you'll see is you'll hopefully go back with 10 things, 5 things on ingestion with Kinesis, and 5 things on building applications with Kinesis Client Library, which is a free open source library that ships as part of kind of the Kinesis service to help you build stream processing applications. Perhaps even more excitingly, I have with me on stage Nick Barish. Nick is an SDE at Adroll, one of the leaders performance marketing ad tech companies in the world, and they've had some great experience in rolling out Kinesis in production real-time on massive scale real-time data streams. And Nick's going to present, of course, a practitioner's perspective. But what's also interesting is that they've built a lot of their infrastructure, the processing infrastructure that consumes from Kinesis streams using Storm. And so this is important so that you get a good view for what it means to build your processing applications using a framework that is not KCL-led. So that's kind of the thought process over there. So Amazon Kinesis Streams, focus of this session, focused on developers, allows you to have fine-grained control over partitioning, scaling of data, and then building your own custom stream processing applications using a framework of choice. Amazon Kinesis Firehose is the stuff we announced today to easily load data streams into destinations like S3 and Redshift without writing any code. And this is available broadly. And Werner announced today Amazon Kinesis Analytics, which is kind of the third member of the Kinesis platform, which will enable you to do SQL querying directly on data streams. That is not the focus of this session, right? So standard marketing slide, 3 things about Amazon Kinesis Streams. You create a stream, you provision it to the capacity you want. You can change that capacity at any point, matching your data throughput rate and volume. So it's relatively easy to administer. You then build your processing application using your framework of choice. And overall, it is a low-cost platform. You can exert a lot of control over the workload itself and overall, and therefore the cost that you incur. So Kinesis Streams started it all. 2 years ago in this very forum, we first announced Amazon Kinesis Streams. Going to give you kind of the high-level gist of it. All data you put into a provisioned entity called a stream gets 3-way replicated across availability zones. A replayable ordered stream of events emerges from that stream, the provisioned entity that you've created. Once you do that, you can use something like the Kinesis Client Library to build your custom applications deployed on your EC2 instances. It's a lot of control, a lot of flexibility that you then trade off for the corresponding work that you do. KCL is not the only way you can build an application. You will learn today how Adroll have built their consuming applications using Storm. There are several other connectors available, including for the broader Hadoop ecosystem, of course, Storm, Spark Streaming, and so on. But my focus will be to kind of talk to you a little bit more about the Kinesis Client Library. So those are the 5 things dedicated to that. Okay, so let's dig into details. Streaming data ingestion. So how do you put data? So you provision an entity called a stream. A stream is composed of units of scale called shards. A shard can do a megabyte per second ingress, 2 megabytes per second egress. There's a 1:2 ratio on the data capacity of any given shard. How you put data is that your data producer does a put API call. There are a couple of versions of it. There's a put record and a put records. We'll talk about put records in more detail next. You put data, the size of a single record can be no larger than 1 megabyte. What we notice typically with streaming data is that the individual discrete record tends to be much smaller, kilobyte, even sub-kilobyte. But with Kinesis, you have some flexibility to put up to a megabyte-sized payload, if you will, into your stream. An essential component of the put call is a partition key. You supply the partition key gets MD5 hashed, and then that is distributed across the corresponding shard into your stream. We return success for each record put by way of a sequence number, and as of a month ago, we are also affixing an approximate arrival timestamp on all the records that are successfully put in the stream. We've chosen the name approximate arrival timestamp very specifically because that is what it is. Okay, so let's start digging deeper. For those of you who are getting started with Kinesis, and for several of you who kind of made a lot of progress, you fall in one of two camps. You'll fall in the camp that looks at Kinesis and says, I've got a great low-cost, highly performant managed buffer, right? And I would fully expect that about 65 to 70% of use cases, not customers, use cases will fall in that camp. So what is really that use case about? It's about your data producers, log servers, smartphone application, mobile application, sensors, so on and so forth, are producing a rapid rate of data. You want to make sure that you capture all the data first, and you create this kind of reliable buffer in there. If your use cases of that kind, then the partition key construct that we talked about, that goes inside of each put call that distributes the data across your stream, can be random. If it's random, then it's less likely that you will hit upon any sort of a hot partition key and therefore a hot shard problem, right? In that situation, your data producer, as long as you're able to generate a sufficiently high cardinality of partition keys to the shards in your stream, you will be more or less okay. We'll talk more about what it means to split a shard when you actually need to on a subsequent slide. But the key thing is when you look at your use case, do you care about the partition key construct? Can you put any business logic around it or not? A smaller segment of use cases will belong in the world that says, I want streaming MapReduce. And why is that? Every time you put data with a given partition key, it always gets routed into that specific shard. Right? So in effect, all records put on a partition key are getting naturally aggregated. So it is, in effect, a mapper function. And this is interesting because on the consumer side then, you will retrieve all data associated with the partition key. So for those of you who are pretty deep with the MapReduce model will appreciate how this translates a little bit into that exact model. In your case, you will design the partition key strategy to be something specific for you. For instance, you want to aggregate all data belonging to a given client. This might be their metering data. You might want to aggregate all data belonging to being generated by a given company because you are generating metered usage for them. If you're in the financial services space, you want to track all transactions that happen, all trade transactions that happen for a given stock symbol. So you want to put data associated with a given stock symbol with a given partition key or set of partition keys. So you need to design a partition key strategy that then makes the most sense in that specific use case. Okay, so let's say now you've kind of figured that out. Great. Now you go figure out how to put data. In the vast majority of cases, what we've learned is that the best way to get to high frequency puts into your Kinesis stream is to use the put records API. Now, the put records API can support up to 500 discrete records in a single call. The overall size of the API request itself can be up to 5 megabytes. So you can do the math as to how big an individual record can be such that you don't violate the overall API request size while not violating, obviously, the individual record size constraint as well. So the different records in that in that put records call can have different partition keys, but it's obviously being directed only to one single Kinesis stream. So just like before, a successful response will give you a sequence number and also the shard ID, which basically tells you which shard was that record routed into. So that's easy. The more interesting case is when you get an unsuccessful response, because this is not an atomic operation. So out of 500 records that you put, maybe the 7th, 418th, and the 352nd failed. So in those cases, what you're going to get is a response object that looks something like that. This was the number of records that failed, and then for each record that failed, you'll get an error code and error message, and what potential error code and error message. So what does it look like? It looks something like this. So if this is an example of a put records response. The first one succeeded. It returned a sequence number and a shard ID. The second one failed, and the error code is a provision throughput exceeded exception, and it tells you that it happened because the rate exceeded for the shard ID many zeros followed by 1 in stream name called example stream. Okay, so now you're going to get the response object back, and you can detect, well, which ones, how many records failed in that put call, and what reason did they fail for. So for those of you who have any experience with provisioned systems will know that the provision throughput exceeded error is kind of your nemesis. We'll talk about how to deal with that a little bit in the Kinesis construct, but the key thing is that's the error code that we've experienced is the one you will watch out for the most. Okay, so now that your producer then has to examine if you do care about getting those failed records back in, and you're not tolerant for any data loss because of the producer not able to put data successfully into the Kinesis endpoint. You'll examine that object, you'll check the fail count parameter, and for each put records entry, non-null entry, for error code, you'll have to package into a secondary follow-on put records request. Cool? Okay, that sounds like a big pain. So sometimes it might be a great idea to use this other thing, a Kinesis producer library. So this is also an open source library that we've put out. It's highly configurable. So instead of writing the application using put records for your producer, which might be required in certain cases, you could also use this producer library, build that into your data producer application running across, let's say, your fleet of servers. This is targeted for server-side environments, not, let's say, a mobile client that is putting data into your Kinesis stream. So it's definitely kind of for server-side environments. And you can have the Kinesis producer library, which can write to one or more Kinesis streams, and it has an automatic reconfigurable mechanism. It collects the records that are being generated by the producer. It uses put records, which means, as we learned, you can put multiple records in a single API across multiple shards in your stream. It can track the record age and enforces buffering times. Over here you have an example of the this is an instance of the Kinesis producer configuration class. You can then pass this on into your Kinesis producer constructor, or you can load a configurations file from where you can set those properties. The key thing over here is that the Kinesis producer library plays really well with the Kinesis client library, which we'll talk about a little later. More specifically, where they play really well is, let's say you are aggregating data to send a single larger record, which is a mode that the KPL also permits. The Kinesis client library, on the other hand, can unpack that and then expose to you the raw records, so that then you can go about and do your processing. So there's one less important code function that you need to write on the consumer side. And perhaps most interestingly, for many, it also emits CloudWatch metrics, so now you can keep track of how your producer is doing. So that's very useful, something that we recommend. And the GitHub link is right there, I guess, that you can pull that down and integrate the Kinesis producer library. Okay, so now you're on your way to doing lots of great high throughput puts, either using the put records API or the KPL. This is probably the #1 most requested feature since we launched 2 years ago. Kinesis streams launched with a default 24-hour retention period, which meant that, great, 24 hours data is safe. But if your consuming application, for whatever reason, does not is down and does not come up for a long enough period of time, such that it's unable to catch up on that data, it meant that the oldest 24-hour data would start getting expired from the system. As a customer, you would see that as a data loss. So now we have included configurable retention up to 7 days. This comes with 2 new APIs, increase and decrease stream retention period. By default, it's 24 hours. We think it's going to be very useful for obvious reasons. The 3-day weekend storm, the pager snafu, and so on and so forth that we all have to deal with. But one of the most interesting modes of operation is that you can happily run with the default 24 hours. You step into the long weekend and you discover that on Saturday evening something bad's going on. You can at that point use it as an always on, you can use it as a response to an operational event. So, for those in lean manufacturing now, obviously in DevOps mode, it's an and-on chord. You can use it as an and-on chord. So when the event is happening, you can say, hey, increase my stream retention period right then, which means all the data that was already in the stream will now not age out at 24 hours, but will age out only at whatever other increased time frame you've had. So it can help kind of save the situation, if you will. And of course, if your default mode is that you want to run the stream with 3 days or 4 days of retention, because you want to run back testing against data that was 3 days old in your stream with your current data in tandem, because you're cool like that, you can also do that. Okay. Let's deal with topic number 5, kind of halfway through my portion of the talk. So as I said earlier, provision throughput exceeded exception errors will be your nemesis. This is true for most provision systems. So you can always run over provision. Thankfully, Kinesis shards are relatively inexpensive. And so we've noticed in practice that in many cases, customers actually run a little over provision. But that's not a satisfactory answer, right? So 2 things. Number 1, you got to keep track of the metrics. While we will do the work needed to expose more metrics, the ones that we should care the most about from an ingestion standpoint are written down, are on the slide in there. I'm not going to read them, but you can imagine the amount of data that you're putting, the incoming bytes, records, success rates, and latencies are all in there. While there is a split shard and a merge shard API to help scale your stream up or down, it can be operationally complex to implement in practice. And I think Nick will also touch upon that in his talk. So to help you get started, there is a scaling utility that can monitor your stream, and you can set it to say, increase my shard count by 20%, or decrease my shard count by 5%, or increase my shard count by some specific absolute number, 15, in response to an event. So it's a good way to get started so that you don't have to necessarily work with the very lower level split and merge shard APIs. Okay, but the important thing here is that errors like these can happen, and from an operational readiness perspective, you need to know what tools you can use to make sure that Kinesis can respond to that event with your control. Okay, now we're going to switch directions a little bit. We talked a lot about putting data, so 5 things to help. What we've learned over the last 2 years that customers ask us about the most, right? Okay, so now let's talk about the 5 things customers ask us about the most on the Kinesis client library. And for those of you who don't know what the KCL or the Kinesis client library is, let's do a really quick overview. The client library is free open source library for you to build stream processing applications. You have a tremendous variety of choices on how to get started with stream processing applications. We love all of them. This is one of them that we've built for developers. What does it do? So think about building your application with this library. You run it on your EC2 instance. What it's going to do is registers with the stream, so it connects to that Kinesis stream you wish to consume from. It'll go ahead and enumerate the number of shards. So they have a 5-shard stream and say, okay, I've counted 5 shards, shard ID 01 through shard ID 05. And then what it's going to do is that it's going to build out a shard management table. So for every single shard, it's going to say, okay, what I'm going to do next is spin up a worker on this instance where I'm going to spin up an entity called a record processor, and I'm going to have a record processor per shard in the stream. So it's going to do the record processor shard and shard allocation. It'll pull the data records from the shards in the stream, and then pushes it to the corresponding record processor that is supposed to consume that data. It'll help enable checkpoints, so you can say, hey, after every 1,000 records that I see, I want you to write a checkpoint. So for every record processor that is attached to every shard in your stream, you get a checkpoint. And then if your stream scales, so let's say you've used the scaling utility, you've added 10 more shards to your stream, the KCL detects that because it's constantly enumerating the shards in your stream. It's going to say, hey, listen, looks like I see 10 new shards. I need to spin up 10 new record processors across my set of EC2 instances. And it'll balance these associations as the stream scales up or down. Let's look at a picture that says the same so that you get the concepts just one more time. So this is the only higher level slide here in this topic. You have an application. The application is named. You deploy it on an EC2 instance. You can deploy it on many. But per EC2 instance, there's a thing called a worker. The worker runs record processors. The record processors map to shards. KCL takes care of all of that. Your business logic sits in the record processor. KCL does its magic of enumerating shards and keeping track of who's doing what, and then populates every record processor with the get records call results that is pulled from the underlying shard. And as I said, all your business logic lives inside of process records. Only if life were that easy, right? So what's going to happen is you're going to spin up your first application, and you're going to have it start consuming data from your Kinesis stream. And one of the first things you'll say is, I'm getting a bunch of empty records, and I know I have data in the stream because I'm putting it, and because Ari said I checked the metrics too, and data is indeed being put into my stream. So what gives? So the consumption model with Kinesis and Kinesis applications is a pull-based model. So the developer here is expected to call get records in a continuous loop with no backoff. So every call to get records will return a shard iterator value. So what is a shard iterator? A shard iterator is basically a cursor of the reader on the shard. So it's a position within the shard to tell you which record am I reading right now inside of a shard. And because there are multiple shards and potentially multiple consuming applications, each of them gets their own shard iterator. So the get records operation does not block, and returns immediately with either the relevant data records that it's pulled out or with an empty records element. Now, an empty records element, in turn, can be returned under a couple of conditions. One, there is legitimately no more data contained in the shard. Or the more nuanced one is that there is no data near the part of the shard that is pointed to right now by the shard iterator itself. And this condition is subtle, but it's kind of a necessary design trade-off to avoid the condition of an unbounded seek time, which essentially will translate into a very long latency, right? When retrieving records. So what's the net of it? The net of it is that the consuming application needs to loop and call get records and handle the situation around empty records as a matter of course, right? As a part of the overall processing. Now, in the production scenario, the only time this happens when the continuous loop is exited is when the next shard iterator value that you get is null, right? And when it is null, it means that the current shard is closed. And the shard is closed typically after, let's say, you split a shard into two child shards, and in the life cycle of a shard, it goes from open to being closed, which means this shard cannot be written to anymore, although it can be read from until its retention period expires. When the next shard iterator is null, it means that the current shard, as I said, is closed, and that the shard iterator value otherwise would be pointing to something past the last record, which wouldn't make sense. Now, if the consuming application never calls the split shard or the merge shards, then the shard remains open, and the calls to get records would never return a next shard iterator value that is null. So if you use the KCL, the above consumption pattern is largely abstracted for you, which includes kind of the automatic handling of set of shards dynamically change. And the important thing here is that as a developer, you take care of the scenario when there are empty records being driven out of the shard as part of a get next records call. Make sure you're calling a continuous loop. Okay, topic number 2. Some records are skipped, right? And the key here is that the process records business logic is where you'll have to handle this exception. Because the KCL is abstracting a bunch of stuff for you, it will tend to absorb a number of these situations. And what you will need to do is to kind of, when there's recurring failure and you don't want to get into the situation of having infinite retries, do not resend the batch of records back into your process records, else what you're going to do is purposefully skip those records. So because the way it works is that process records for every next batch of data without restarting the record processor itself. So the key thing here is that in the process records logic, just like we talked about dealing with empty records that are returned, you'll have to do a little bit of work to handle this specific exception as well. And to kind of help shine some more light here, we also have a ton of shard level metrics which are very frequently not used, which is kind of sad. So there are a bunch of service level metrics. That's great. But when you use the Kinesis client library, you actually get a very deeper set of metrics on a per shard level, which you can then use for a variety of reasons, including saying, am I running slow? Am I running behind? Is there more data in the stream that I should be consuming? Is it the right time for me to be scaling the stream? And a lot of that great information is stuffed inside of these shard level metrics, which are turned on in KCL by default, and they're emitted into CloudWatch. So if you go into your CloudWatch metrics console, you will see on a per shard basis for every KCL application, all of these metrics. Okay, another topic, very common. And for those of you who are either already in production or will get started with streaming data, will come across this. This is a near real-time system. Data is continuously being generated, being put, and being consumed. And what you don't want is for the system to slow down. But there might be scenarios when you go, well, the consumer is reading slower than expected. So what's going on? But the most common reasons for the read throughput, if you will, being slower than expected is as follows. Kinesis allows you to have multiple different applications consuming from the same stream, and more specifically, consuming data or reading data from the same shards. But it does have limits, right? Each given shard has 1 megabyte per second in, 2 megabytes per second out. It can do 1,000 records per second ingress, and it does 5 reads per second egress. Now, some of you are probably shocked. Wait, that makes no sense. Now, the good news is that a single get records call can return up to 10 megabytes of data. So you're getting a little bit of a bash functionality when you retrieve data from the shards in your stream. The bad news is that there are just 5 of those calls that you can make. So if you start attaching multiple consumers, by which I mean independent applications, you might come across a situation where capacity is fine. So you have all the data that's in, you have enough read capacity in terms of the data being pulled out, but you get throttled on the read TPS. An obvious thing is, well, we should go fix it, yes. But having said that, if you get a provision throughput exceeded error, the key thing is it can happen on ingress because you're putting more data at a higher rate than the shard can take, but it can also happen on egress, right? However, what we notice, let's say that if that is the situation, it is somewhat relatively, you can address it by simply splitting shards. So if you have more shards in your stream, you are less likely to run up against that specific problem. But let's say that is not the issue. What we notice most often when we go and help debug code with customers is that the maximum number of get records per call limit has been configured to a lower value. right? So as I said earlier, the maximum get records, we can retrieve 10,000 records in a single call, right? And it's actually a very efficient call to go ahead and do that, which is actually the system default. And we've noticed that normally there is little to no impact over there. When someone tries to configure it to a lower or a different number, you see more often than not, this problem arise without necessarily having optimized the system. So this is one of those cases where the system defaults might actually be a good idea. Now the other obvious reason is that the logic inside of your process records is just taking longer than expected. And this happens a lot too, which is my application is running slow, I don't know what is going on. And most often, when we have the conversation, it is about, no, my application is perfect, all right? It is doing exactly what it's supposed to do, but still it's running slower. And therefore, the problem is on the Kinesis side because you're unable to retrieve records fast enough. And typically what we've noticed is, in that case when that does happen, and then we go how to figure out how to fix that. But in most cases, what we've seen is some application practice of writing process records has resulted in just a very CPU-intensive logic, something that could have been written a little bit more efficiently, or there is some sort of I/O blocking, in which case always start with making sure that you can run an empty record processor. So record processor is just getting records and doing nothing else to see if your application is pulling data from the Kinesis stream fast enough. Okay, fourth topic, and I'll move a little quicker. If you remember, there should be one record processor per shard, right? That's how the KCL allocation occurs. But it can be the case that sometimes multiple record processors are temporarily processing the same shard. Now, a given worker running on an EC2 instance loses network connectivity. The KCL thinks that, oh, that guy's out, I need to go spin up another record processor to take its place to make sure that the continuous processing is happening. So it spins up a new record processor, but the other one wasn't out for a long time. It was out for only for a very brief moment in time. And so it suddenly picks back up, and it also starts pulling data from the shard. So now you have two record processors, both of whom are consuming data from the same shard. Now, that is supposed, the behavior of KCL trying to spin up record processors, move the data using the checkpointing mechanism is something we want to do, right? We want to do that because that kind of a logic helps keep things relatively simple and keeps things robust and going. But in this specific case, when this does happen, there are a couple of cases where graceful shutdown has to be performed. And again, from a developer standpoint, this is what you'll have to keep in mind, right? Whenever the current call to a process records is completed, in this case, KCL will invoke a method with the zombie reason, shutdown reason. And at that point, the record processor's ability to gracefully shut down, exit, and clean up is part of coding best practices that has to be put in. Because very often we've seen unclean exits, meaning that there is some zombie record process that's continuing to read from a shard, which was completely unexpected behavior. Okay, last topic. Duplicates. It's the streaming data system is distributed, lots of data coming in, duplicates can happen. Duplicates can happen in two places. One is your producer re-putting data, or because the internet happened, it put data, maybe it was successful, but the act got lost in the way. Happens all the time. Tough problem to solve. That's not what we're targeting right now. What we're going to target instead is when consumer retries. So on the processing side, stuff is causing duplicates, because this is something that can happen with the KCL, and I want to make sure that you guys know how best to deal with that situation. So, very quickly, there are three reasons why you might see temporary rise in duplicate processing. You know a little bit now about the record processor shard model and how the KCL operates. If a worker terminates unexpectedly, the EC2 instance disappears. You have new worker instances being added or removed, which means KCL is trying to move record processors and the shard allocations around, or when shards themselves are being merged or split. All these three conditions can lead to a temporary condition where retries are happening, and therefore the same data is being pulled and then reprocessed inside of the KCL and the record process within. How do you deal with it? Now, while I would love to stand here and tell you about how exactly one's processing semantics are super simple and they've all been solved for, what we've no, it hasn't happened yet, or it has only happened with enormous amount of difficulty. Pragmatically speaking, what we've noticed is as follows. Make your final destination where that data is going to land to resilient. Arguably, it's the most pragmatic approach that we have noticed time and again has helped 85% of the cases. Your mileage, of course, may vary. Very likely that you're using something like Dynamo, S3, or perhaps another durable mechanism to get your final state of the data in. One of the mechanisms that we've used to kind of mimic idempotent processing inside of the KCL tends to work pretty well. And it goes as follows. So you have a record processor. You can tell the record processor, always process, and you can set that in the configuration properties, always pull 5,000 records. OK, after you do that, you choose a file naming schema that might look something like what's on the board. So you can say, in this case, let's say we're putting data into S3. So you can say the S3 prefix, the shard ID from which the process records is pulling data from, and then the first sequence number within that batch of records, all of which is available in there. OK, so let's say that you upload the file into S3 and you checkpoint, because you have, again, the ability to checkpoint via KCL, the last sequence number. And let's say in this case, because you're pulling 5,000 records, the last sequence number, last record number will be end in 15,000. Let's say it started first at 10,000. So let's say that something happens and you end up repulling data. You're repulling data and you're processing the same data twice. But if it pulled from the same sequence number, it's going to end up rewriting based on that specific schema. So at the very minimum, what you've done is you haven't created an overlapping file. You ended up rewriting the same file as part of your process records. And this is an example of how you can, I guess, hack your way into getting to an idempotent processing model. And of course, we can do much better. OK, all that was super cool. You can send and read data from a variety of different mechanisms, get APIs, KCL. But the one that I'm most excited to kind of share with you is the work that Nick and the team at Adroll have been doing with Kinesis and Storm. Nick?
Thanks, Eddie. Hey, I'm Nick. I'm a software engineer at Adroll, and as Eddie said, for my portion of the talk, I'm going to be kind of covering some of the work that we did to roll out Kinesis in our real-time data pipeline, which is primarily driven by Storm. So more specifically, some of the things I'm going to cover are what our real-time data pipeline architecture looked like before we started using Kinesis and why we were motivated to make the switch. I'm going to cover some things about how we set up our producer and consumer applications and some kind of best practices in there. And finally, I wanted to talk about some of Kinesis's service constraints and how they'll affect how you want to architect your real-time data pipeline, especially if you're going to be having lots of applications concurrently consuming the same data from a single stream. So a quick blurb about Adroll. We're a performance marketing platform, and we enable brands to use their data to run intelligent, ROI-positive marketing campaigns. We're probably best known for doing retargeting. I don't know if any of you have ever had the experience where if you're shopping online for something like a refrigerator, and then suddenly, after viewing a refrigerator on someone's webpage, you're kind of chased around the internet for ads for a refrigerator. That's us. All right, so to do things like retargeting, we leverage a number of real-time data sources. So for one, we're collecting clickstream data from our advertisers' websites via a JavaScript tag that we have our advertisers place on like the footer of their website that kind of forwards us data about what URLs the users that we've cookied are viewing. We use this data to build user profiles and inform our real-time bidding systems, which are powered by machine learning, which users are most valuable to your brand, aka which users you should be showing ads to, and also which ads you should be showing to these users. We're also constantly collecting data on the ads we're serving. So we want to know for each impression, was it clicked? Did it drive some high-value user action or conversion, and so on. And also, we constantly need to monitor all of the real-time bidding auctions we participate in across a number of different exchanges. We want to know how often are we winning, what's our average win price, and that kind of thing. So recency is very much directly correlated with performance in most of these use cases. And the sooner that we can act on our data, the better we perform, the more opportunities we get to kind of drive revenue and show ads. And here's kind of a quick snapshot of kind of some of the scale of the events that we're dealing with. We serve around 200 million impression events per day, or something like 1/4 of a terabyte of logs are involved there. We process about 1.6 billion clickstream events from our advertisers' websites, or around 700 gigabytes of data per day. And finally, we participate in about 60 billion real-time bidding auctions per day, and that involves processing something like 80 terabytes of data per day. And as of right now, this is the data that we're piping through Kinesis. There's no practical reason why we couldn't also pipe our RTB data through Kinesis, and that's definitely something we'll probably be evaluating in the near future. But yeah, this is the slice of the data that we're currently using Kinesis to process. And so here's what our architecture looked like before we moved to Kinesis. So we had a bunch of log producing systems, which are our real-time bidders and our ad servers. They constantly are generating logs. And every 20 minutes, they'll flush the data that they've generated into a separate log file per host in S3. Then we used Lambda's integration with S3 events to figure out which file paths are for the newly generated log files. We'll forward those file paths to a set of SQSQs, which are hooked up to our real-time data processing applications. So those applications pull the SQSQs, download the corresponding files that are in the SQS messages, process that data, and then flush to our various end-of-pipeline data stores like S3, DynamoDB, and our own HBase. So because we're flushing logs, or we were flushing logs every 20 minutes, on average for any given event, for any given log event, it was 10 minutes before it was made available for processing in S3. And also because we're dumping so much data at any given point in time, it would usually be something like 5 minutes before any given event would be processed, even after it's made available. So end to end, our data processing latency in this old data pipeline architecture was something like 15 minutes. And as I was kind of alluding to before, every second that we wait means kind of a missed opportunity. And so we were very much motivated to kind of reduce this latency that we were experiencing. And of course, we could flush logs more often to S3. So say we flushed our logs on a 10-minute interval instead of a 20-minute interval. Theoretically, that would reduce our end-to-end data processing latency, but that would also mean we were generating more and more smaller and smaller log files as we kind of reduce that interval. And that kind of starts to kill our S3 performance. And so we found flushing logs every 20 minutes kind of was a nice happy medium between the tension of maintaining S3 performance while also kind of optimizing for latency. But that also meant we were kind of bound to 15 minutes end-to-end processing timeline in this architecture. So yeah, we were motivated to move to a streaming service and kind of switch out the back end of our data pipeline, and we came up with a list of requirements. Most of these are pretty obvious. We want it to have low latency. We want it to be able to scale up to handle our data load. We would want our streaming service to be fault tolerant and probably replicate our data to make our data more durable once we put the data in the streaming service. Highly available, of course. And finally, we wanted the streaming service to be globally deployable so that we could, the motivation here would be we'd want to host our streaming service near our log producing applications so we could flush logs from our log producers as frequently and as reliably to our streaming service as possible because the less often we can flush logs, kind of the more data is constantly sitting on our log producers, and the more risk we're kind of assuming if one of those log producers were to die, we'd probably lose that data. So we want to get our data into our streaming service as quickly as possible. So given all these requirements, we actually decided to try out Kafka first. This was something like 2 years ago, I think, and I actually wasn't a part of that project, so I'm probably not the best person to ask kind of for a big rundown on why Kafka didn't work out for us. But kind of some of the themes were we had like lots of little issues with getting it set up and kind of getting it tuned. We had issues with things like allocating the appropriate amount of disk space per topic, setting up cross-data center mirroring, and so on. And in the end, we kind of decided that it wasn't worth it to spare all the human resources that it would have required for us to maintain our Kafka deployment. So we kind of abandoned that project. So we added the requirement that whatever streaming service we chose would need to have kind of a low ops overhead, a low management overhead. And naturally, that ended up leading us over to Kinesis. So again, in our old data pipeline, we were essentially just dumping all of our data into S3. To move to Kinesis, all we really had to do was dump our data in Kinesis now. And once we started doing this, we pretty much immediately saw our end-to-end data pipeline processing latency drop from 15 minutes to just 3 seconds per event. Obviously, this was a huge win for us. And I guess a quick note, it wasn't quite this simple to re-architect our data pipeline, but I'll get more into that later, so keep that in the back of your mind. So here's a quick snapshot of our Kinesis usage. So we have Kinesis streams hosted in 5 different regions, 5 different AWS regions. And across all that, we have 155 streams, 264 shards, and we're shoving about 2.5 billion log events into 100 million Kinesis records per day. And for all this is actually a screenshot from our billing page. We only pay about $3,000 a month, which is pretty awesome. It's actually cheaper than the rent that I pay in San Francisco, sadly. So besides the recency improvements, we actually scored a number of other wins when we moved to Kinesis. So here's actually a graph of DynamoDB writes coming from one of our real-time data processing applications. This is over something like an 8-hour window, and within this window of time, we rolled out Kinesis. Hopefully, it's pretty obvious where the transition occurred. So back when we were dealing with these kind of bursty batch workloads in our old data pipeline, we had to provision DynamoDB for the peak of our load spikes, and you pay for provision throughput on DynamoDB, so we kind of had a lot of this wasted throughput capacity in all of kind of the quiet parts of our load graph. But once we moved to Kinesis, it really smoothed out our load, and we were able to drop our DynamoDB provision throughput capacity on most of our tables, something like we were able to cut it in something like half, which saves us a ton of money. I think we're one of, if not the biggest external consumer of DynamoDB, and so this saved us a ton of money. I think this saved us something like 25 times the amount of money that we're actually spending on Kinesis for like the same period of time. So this was a huge cost saver on top of all the recency improvements, which was awesome. And also just smoothing out the load was great for system stability in general. I get paged for this system in the middle of the night, much less since we rolled out Kinesis, so Kinesis was good for a good night's sleep as well. All right, so moving on to some notes about our producer setup. Right now we have something like 300 servers constantly generating logs and flushing that data to Kinesis at something like 700 records per second per host. And most of these applications, most of these Kinesis producer applications are written in Erlang. And to interface with Kinesis there, we wrote our own in-house Kinesis client in Erlang, which we've open sourced. And all one of you that use Erlang can check it out on GitHub there. So here's some kind of best practices we adhere to on our Kinesis producers. Sorry, the formatting on the slide kind of got a little bit mangled there. But one thing that we do is we don't flush each of our log events in a separate Kinesis record. As we're generating logs, we're kind of constantly concatenating them together, and then we'll only flush our like little micro batches of logs once that batch reaches a kind of critical mass of 1 megabyte, which is the maximum amount of data you can put in a single Kinesis record. Or if our data is relatively low volume for whatever data we're trying to pass to Kinesis, then we'll also flush on a 1-second interval if it's been 1 second since the last time we flushed, so our data doesn't just sit on our log producers and become stale. So it turns out this is a huge cost saver for us because part of Kinesis's billing is this notion of put payload unit, where you pay for every fully used or partially used 25 kilobyte chunk of data in each Kinesis record that you flush to Kinesis. Our data tends to be something like 1 kilobyte in size. So suppose we had 25 logs that we wanted to push to Kinesis. If we pushed each of those logs in its own separate record, we'd be paying for 25 put payload units. But because we're batching them together and flushing those all in a single record, we only pay for 1 put payload unit. And I think this saves us something like 2/3 of what we'd otherwise be paying on our Kinesis bill. So instead of paying $9,000, you're paying $3,000 per month. If some of our data isn't making it into Kinesis, oftentimes we'll see kind of a direct revenue impact. So we tend to be pretty aggressive with our retry logic, and some super common sense best practices there are exponentially back off for successive retries of putting data into Kinesis. And also if you're flushing data on a consistent time interval and you're running into issues with hot shards, consider introducing some jitter, simple stuff. Also, because we batch our data together inside individual Kinesis records, it'd be tough to do anything fancy with partition keys. So we just kind of use randomized partition keys and let our data fall where it falls. And then we have the mandate that our downstream applications have to handle kind of sorting and grouping of the data that they need to do to process whatever data they're processing. All right, so moving on to consumers. We have something like 12 major applications using Kinesis right now. We have a couple Erlang applications, but for the most part, we interface with Kinesis using Apache Storm. And to interface with Kinesis there, we've used a slightly modified version of Amazon's Kinesis Storm Spout library, which you can check out on GitHub. And I kind of wanted to get into one specific optimization we made to some of the code in the vanilla Storm Spout library that Amazon wrote. So here's a snippet of code from Amazon's version of the library. Storm's constantly hungry for data, and so it's constantly polling this getNext method, whose only job is just to grab data from Kinesis and kind of return it to the topology for processing. And each time getNext method is called in the vanilla version of the library, a request to grab data from Kinesis gets kicked off. And this is actually a synchronous request, so once this request gets kicked off, your main application thread will just kind of sit there blocked, waiting for the network round trip and for whatever magic happens behind the Kinesis endpoint to give you data, waiting for that to complete before emitting the data for the Storm topology to process. So we found this wasn't quite as performant as we would have liked it to be. So we ended up rewriting the code that pulls data from Kinesis something more like this, where instead of grabbing data in our main application thread, in kind of a background thread, we'll be we'll constantly kick off requests to grab data from Kinesis using the Amazon Kinesis async client instead of the synchronous call. And then in our callback, we buffer whatever data was returned by Kinesis in some sort of concurrent queue. And then when that request completes, we just constantly kick off another one. So in the background, we're constantly pulling Kinesis and constantly buffering data in memory in our concurrent queue. All the while, our main application thread is still calling this getNext method, just like it was before. But instead of making a request directly to Kinesis here, all we do is pop whatever data we have buffered on our concurrent queue. And then we're not wasting cycles on network round trip and that kind of thing. And I think from making this relatively simple change, we saw something like a 10x data consumption velocity speed up for our Storm topologies. So definitely something to consider if you're ever interfacing with Kinesis using kind of the raw Java SDK. Use the asynchronous requests if you need to access Kinesis performantly. All right, so for the last part of my talk, I kind of wanted to get into some of Kinesis service limitations and how they might affect how you want to architect your data pipeline. So as Addy mentioned before, there's kind of this restriction that when reading data from shards, you can only do 5 transactions per second. So, oh, sorry, this got cut off too. What it says there is it's tough to have a large number of applications per stream. So suppose like AdRoll, you have something like 10 applications that want to concurrently consume data from a single stream. What you'd have to do is have each of these applications do something like making coordinated 0.2 megabyte reads every 2 seconds. And this gets further complicated if you ever need to introduce transient applications, like say you need to spin up a testing application and kind of plug it into a stream, or if you need to do some ad hoc processing on some section of the data that you have stored in your stream right now. You need to have all of your long-standing consumer applications adjust their polling intervals. And this kind of becomes this big coordination mess. And so it turns out life isn't quite this simple. But there are a number of solutions that you can do to kind of get around this if you have multiple applications that need to concurrently consume data from a single stream. So one solution is to have multiple layers of Kinesis streams. So here you'll have your log producers flush data into kind of an initial layer of Kinesis streams. And then you could have, say, a KCL application kind of in the middle of your initial layer of Kinesis streams and your real-time data processing applications, whose job is just to route this data into a set of application-specific Kinesis streams. Because each application gets its own stream, there's no contention for these 5 reads per second, and there's kind of no scheduling nightmare in trying to pull data from Kinesis. And also, you could have some sort of kind of controller application spinning up new streams and having your KCL application kind of route the data to those new streams as well, without affecting your long-standing consuming applications. One drawback here, though, is this is potentially expensive depending on kind of your cost needs. So there's another alternative, which would be to, instead of flush data into a second layer of Kinesis streams, you could just flush that data back into S3. You could do this using a KCL application, or now that Firehose is a thing, there's no real reason not to just use Firehose to do this for you. So S3 is a great data store for having multiple applications concurrently consuming the same data. But wait a second, it seems like we kind of went through all this effort to re-architect our data pipeline to not involve S3, so why would you want to do something like this? Well, if you recall, in our old data pipeline, we were flushing a separate file per log-producing host. But one thing that this new pipeline architecture allows you to do with Kinesis is aggregate data across all of your log-producing hosts in a single place in your KCL application, or let Firehose do it for you, and flush all that data in a single log file. So remember, we kind of had this problem where we didn't want to generate too many small log files in S3. Well, suppose you have 20 log producers. In our old data pipeline, if you're flushing data every 20 minutes, you're generating 20 files every 20 minutes. But in this new architecture, we have the opportunity to flush data every 1 minute, flush data aggregated across all of our log producers in a single file to S3 every 1 minute. So after 20 minutes, we still end up with 20 files. But in this new way of flushing data, we're making our data available for processing only 30 seconds after it's generated, as opposed to 10 minutes. And depending on your application's SLAs, you can kind of mix and match. So if you have some applications that need to process data within 5 seconds of it being generated, then you can have something route that data to Kinesis stream. Then for other applications that might have more relaxed recency SLAs, you could have those applications consuming from S3. So yeah, that's kind of most of the points that I wanted to make. So going back over some of the main points from my portion of the talk. One, consider hosting Kinesis near your data producer applications to facilitate offloading logs kind of as quickly as possible so that your data isn't sitting on your log producer boxes where it's kind of in a single point of failure scenario, where if your log producer box falls over, then you might lose data. And once it's in Kinesis, it's three-way replicated, so it's probably going to be much more durable. And yeah. It's better, it's potentially cheaper, and it's probably going to be more reliable to work with a smooth, constant workload that streaming services afford you, as opposed to kind of the issues we had dealing with bursty batch workloads. So if you're kind of like us and you're coming from a batch workload for your real-time data processing, definitely something to consider. There's probably some gains to be had there. Think about batching data inside Kinesis records, especially if you're like us and you have kind of small chunks of data that wouldn't fully utilize the Kinesis put payload unit of 25 kilobytes of each Kinesis put payload unit kind of cost. Try to use the asynchronous Kinesis API if you're ever working with the raw Java SDK. And then finally, think about putting something in the middle of Kinesis in your Kinesis consumer applications if you think you're going to be having lots of applications that'll need to concurrently consume the same data from the same stream. Back over to Addy.
Thanks, Nick. That was incredible. Hopefully that was interesting to you guys too. So we've got a minute and 50 seconds. So I think we can do 7 questions. And of course, we'll be available right after. So in case you don't like beer and partying, you can talk to us.